We have a variable called myVar, and it is a type D word, and the value is 5. And then I have another one, myVar2. This one is a word, and the value is 4. And another one, myVar3. This one is a byte, and the value is 3. Another thing that you need to know is that assembly language is not sensitive to case, so you can be comfortable there. But it's better to keep the same shape, keep it the same everywhere, because then it's easier to read. Whenever we want to display any integers, we have to make sure that we put that number inside of EAX register. So move EAX, and our D word can easily go here. So I can just put my var here. And then I can either call this with rightInt, which shows the sign for my var, or I'm gonna put a space here, CRLF, or I can write this with rightDec, which is going to give me only the value, not the sign. Okay, so let's first just see this. Okay, I forgot to put E here. I would write int like that. Okay, build solution and debug. Start without debugging. We have +5 and 5. +5 is coming from rightInt, which shows the sign, and 5 comes from rightDec, which shows the only the value. Okay, so this is in the case that our variable is a D word. But what if we have a word, or what if we have a byte? Let's see what we can do in those cases. I mean, that part is going to be the same. I just have to change this part. We have two options for writing the word. First option is to make sure that our EAX is 0, because there might be other values inside of our EAX. So we move EAX to 0, and then we choose a smaller version of EAX register, which is AX. AX is a word. And then if I put my var2 in there, then I have to get 4 and +4 and 4 as a value. So I'm going to build my solution again and start without debugging. So yes, we have 4 and 4. And for byte, again we have to change something. We have to change this to AL, which is the smaller version of EAX. And if I build this and run it, it will run without problem. Oh yes, because I forgot to put my var 3, because this is byte, the other one is a word. So I'm gonna build it and start without debugging, and I have 3 and 3. Okay, so next step is instead of using move EAX to 0 to make sure EAX is 0, let's delete this, and we can use move with 0 extended, and then if it is signed, we can say move with sign extended. So if it is negative, then it will be 1. If it is positive, it's going to be 0. Okay, right now let's do with 0 extended because all of our numbers are positive. EAX, build, start without debugging. It is 3 and 3. So we had these two ways to display our numbers with any type of variables that we have. Now let's talk about addition and subtraction. If I have EAX, I have var3, which is number 3 in my EAX register. Now I'm going to increment EAX. We increment EAX. Now if we build solution and start without debugging, we get 4 because we already had number 3 and then we incremented by 1 and we got 4. Okay, what if we decremented? If we decremented, we have to get 2. And we get 2. And another thing that we can do is we already have our var3, which is number 3, and we have the d word, which is number 5. So what I can do, I can add these two together. I'm going to say add EAX to my var, and then it's going to display it because then when it is added, it's going to be saved inside of the EAX. It's going to be saved inside of the first one. So build, start without debugging, and we got 8. So the numbers were 5 and 3, and if we add them together, we're going to get 8. And then if we subtract them from each other, if we subtract EAX, which is number 3, and my var, which is number 5, we should be getting 2, but let's see if we get it. Okay, so the part that we had rightInt, which was showing the number with the sign, it gave us the right value, but the other one didn't give us the right value. So if we want to use a negative number, we have to make sure that we use rightInt. Now let's do something a little bit crazy. We have target here, and at the end of this, I'm gonna say jump to target. So right now we're using a jump, which is going to, whenever it's gonna hit the target, whenever we're going to get to this line, jump target, it's going to go back to target, and this is going to loop forever. It's never gonna stop. So whenever you want to do while true loop, you can just use jump, and it's going to keep jumping forever. Now let's look at this. It doesn't stop because it is a forever loop. Now let's see what we can do to control our loop and tell it when to stop. If instead of jump we use loop to target, then before that we have to do one thing. We have to move ECX to a number, or in this case we can just say my var, which is going to be 5. So we're gonna loop 5 times. We're gonna do this 5 times and then let it go. Okay, let's make add so both of our numbers are correct, because one of the numbers are incorrect when we do subtraction because it's a negative number. And now I can debug, and this is okay. So what had happened is that we don't have CRLF after the second one, so the second one is coming beside the first one. So what I can do, I can put another CRLF here, and if I build it and debug it, now they're going to be on separate lines, and they're going to be 10, but actually because we have 2 lines of code here, they are 5. So it looped 5 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we looped 5 times. It's because of this line of code. We can have each one of these as an array. There is no problem with that. Let's actually do it with a string array. I'm going to have something called source. I'm going to have a variable called source, and this is a byte, and I'm going to say this is source. This is the end of it. And then I have target, again byte, and this one is going to be size of source. So that means the length of it is going to be, this is source with all of the spaces in here, size of source, and I will use DUP and assign it to question mark. Question mark means we don't know what the value is going to be right now, but source DUP, and after that question mark means have to the size of that there is question marks. Okay, let me explain it this way. We have question marks for every single letters and every single space in here. And then after, when we want to fill our array, we will know that the size is this much. We first have to move ESI to 0 because we want our index to be at 0. This is our index. And then we move ECX, as you remember from the previous program. ECX shows the number of the time that we're gonna loop, and we're gonna set it to the size of source because that's how many times we have to loop if we want to push every single letter of the source to the target. So these are making us ready for our loop, and this is making us ready for our array. And then I'm gonna say loop L1, move, and because we have byte here, we have to use AL. So use AL and then source, and the index is ESI. Now we're gonna move it to the target, and then target is going to be at index ESI as well. And what is going to be moved here? AL. Why didn't we do it straight away? It's because move, you cannot have memory to memory transfer in move. You can have memory to register or register to memory, but you cannot do memory to memory. That is why we need to have these 2 lines of code. And then we have to move increment ESI, because if we don't, then all of them are going to be at ESI 0, ESI 0. We're going to have T in ESI 0, H in ESI 0. It's going to override it, and then after that we're going to be end up with only E inside of our ESI 0, and the rest of them are going to be overridden. So then we have to increment ESI every time we loop, and then we loop L1. And that's it. Now let's see. Oh wait, and we have to do something else too. Outside of outside of our loop, we want to move EDX to the offset of our target, the other way around. We want to move offset of our target inside of EDX, and we want to call rightstring. Build solution. Don't forget these two dots. Don't forget 2 dots for L1. Build solution. And start without debugging. Oops. So as you can see, it says this is source, but it's actually from our target. So because we moved target inside of our EDX, and we call rightstring on target. So that means that's how our array works. If you want, you can just put all of them together. Actually, let's make it numbers, because numbers are going to be a little bit different. They need to have commas in between them. So I'm going to say this is a D word, and I'm going to assign 1, 2, 3, 4 to it, and this is going to be D word again, and it's going to be size of source, and instead of AL we do EAX here, and let's EAX target. We don't need the offset anymore because it is a D word and they are numbers, and I'm going to say right deck. And as you can see, we have 1, 2, 3, 4. Let's talk about push and pop. Move EAX to 5. So 5 to EAX. Right now EAX have 5. And then I'm going to call right deck, so we can see that 5 is inside of EAX. And then I'm going to add some an extra line, and on the next line I'm going to say push EAX and move 6 to EAX, call right deck, so it's gonna display 6. And then after that, I'm going to put another line here, actually, call CRLF, and now I'm going to say pop EAX, and again call right deck. So for the last time that it's going to be that we're going to print the number, I didn't specify any numbers, and EAX already have 6 in it. But now I popped EAX, so now EAX has 5 in it again. So basically push will save the value of 5 inside of it, and then when you pop it again, your EAX will gonna have the same value again. So we'll build solution. And then debug, start that debugging. As you can see, we have 5 at the beginning, call rightDec on it, and then I put a space. On the next line, I assigned 6 to EAX, and after that, I just popped EAX, and it is number 5. So in case you have so many values that you're working with, and they are more than number of registers that you have, you can use this, you can use stack, and you can keep the values and use them whenever you need it. Now let's talk about comparisons. I'm going to put a number like 10 inside of EAX, and I'm going to compare EAX with 0, and I'm going to say jump if it is 0, and to where? To finish. We actually don't have exit here. I'm going to put exit here. So my finish is going to be here, which means it is done, and we can actually say that it is done. My var byte done, and here I'm gonna move edx to offset of my var and call rightstring. Okay. Start. And sometimes you will have failures in your program without any reason, and it's because you probably used some of the words that are preserved for other purposes for your loop, so you can change that word and you're going to be fine. So we are comparing EAX to 0. We jump if it's 0 to finish, and then finish says it's done. And here I'm going to decrement EAX because we eventually have to get out of this loop. And I'm going to say jump to start. So here it keep jumping to start, but if the value is 0, it's going to jump from all of these. It's going to jump dec and jump itself, and it's going to finish. Okay, so let's build the solution. Start without debugging. So we're just gonna have done. Then I'm going to show you one last thing, and that's going to be, I have my var dword for a number, and I'm going to put question mark because I don't know the value yet, and I will have prompt byte, please enter a value, and then we're gonna say result byte your value is, Okay, so I'm going to first say move edx, and prompt is going to be in the edx, call rightstring. After that, call read this time, read int, or if I just want the value, I'm going to say read dec. To save it inside of my var, I'm going to move my var eax, and then call move edx to actually offset. I forgot to put offset here. Offset results, call rightstring, and then call rightdec. Between these two, okay, we don't need anything else. Build and start without debugging. Okay, it is asking us to enter a value. I'm going to enter 3, and there's a heart. I didn't expect that.